For the redox reactions activity, we are working with redox reactions and deciding what's been oxidized, what's been reduced, what's the oxidizing agent, what's the reducing agent. And we are also balancing redox reactions, which is a technique that is not in the lecture notes, but is one that we will learn how to do in this activity. A little reminder of oxidation numbers, oxidation states. For hydrogen within a compound, its oxidation number is +1. For oxygen, except for peroxides, its oxidation number is -2. For a pure element, for a metal, for a gas that's a pure element like Na or Cl2, its oxidation number is 0. For an ion, its oxidation number is its charge. And when an element's oxidation number has been increased through the course of a reaction, it has been oxidized. It has lost electrons. When an element's oxidation number has been decreased, that element has been reduced. It has gained electrons. The oxidizing agent oxidizes the other substance. It itself has been reduced. It has taken on electrons. The reducing agent reduces the other substance. It has been oxidized. It has lost electrons. So let's apply this to this reaction: 2Na solid plus Cl2 gas forming 2NaCl solid, reaction 1. If we look at the two half reactions involved, we see that Cl2 has gained 2 electrons to form 2 Cl- ions. The chlorine has been reduced. That's reaction 2. The other half reaction that has occurred is sodium forming Na plus by giving up 2 electrons. It has been oxidized. So because 2 electrons are involved in reaction 2, we multiply the sodium reaction through by a 2 and have reaction 3. 2Na yielding 2Na plus 2Cl minus. 2Na forms 2Na plus 2 electrons. The electrons are product. They have been removed from the sodium. The sodium has been oxidized. Now, the oxidizing agent is the Cl2. That is because it has caused the oxidation of the sodium. The reducing agent is the sodium because it has caused reduction of the other one. So carefully review the Chapter 4 redox section of your lecture handout and the lecture video so that you're up on the terms and more comfortable with them. Also think about how to determine oxidation numbers of chemicals. That's all in the Chapter 4 handout and the Chapter 4 video. Okay, now the new section is balancing redox reactions. So we will balance this reaction here, Br minus plus MnO4 minus, forming Br2 plus Mn2 plus. Now notice that oxygen is on the reactant side but not on the product side. So we can't just put the big stoichiometric coefficients in the front and call it balanced. It turns out it takes some steps that we will run through to be able to do this balancing. The technique we're using is called the half reaction method, and it involves a number of steps. Step 1 is we write the two half reactions. So we will separate the Br minus and the Br2 into 1/2 reaction. We will separate the MnO4 minus and Mn2 plus in 1/2 reaction. That's step 1. We will balance all the elements other than the oxygen and any hydrogen. So we will ignore oxygen and hydrogen. So we will balance the bromine and we will balance the manganese. Step 3, we will balance the oxygen atoms. So now we pay attention to the oxygen by adding water. We will simply pull water in. Realize that this redox reaction is occurring in water, so we will just pull it in. We see that we have 4 oxygens in the MnO4 minus, so we will introduce 4 waters. In step 4, we will now pay attention to the hydrogen atoms by balancing those. Well, in step 3, we introduced hydrogen. In fact, we introduced 4 times 2 hydrogens. So we will introduce hydrogen on the side that doesn't have it by just bringing in H+. So that means this redox reaction would have to be occurring in acid. Step 5, we balance the charge. Now we pay attention to the Br minus, the MnO4 minus, the Mn2 plus, and all the H plus. So we pay attention to the charge by bringing in electrons. It's a redox reaction. Electrons are given up by what's been oxidized. They're taken on by what's been reduced. So electrons are involved. We see here the Br minus half reaction. In there, 2 Br minus reactants create a net charge of -2, while Br2 on the product side is neutral. To balance the charge, 2 electrons are added to the product side so that the net charge on each side is -2. In the Mn half reaction, the reactant side has a net charge of +7, +8 from the acid and -1 from the MnO4 minus ion, while the product side has a net charge of +2. To balance the charge, 5 electrons are added to the reactant side, so the net charge on each side is +2. Step 6 is we equalize the electrons transferred. So, however many electrons are given up by what's been oxidized, they have to be taken on by what's been reduced. So in step 5, 1/2 reactions should lose electrons and 1/2 reactions should gain electrons. So something loses, something gains. The electrons lost by one species should equal the electrons gained by the other. To equalize the electrons transferred, the entire bromine half reaction is multiplied by 5 in order to create a loss of 10 electrons, while the entire Mn half reaction is multiplied by +2 in order to create a gain of 10 electrons. Okay, now, we still have 2 more steps and then we'll see that happening. Okay, the last step, or the step 7, is we combine the 2 half reactions. Remember, we separated that overall reaction into 2 half reactions. Now we combine them into one overall reaction. We collect all reactant terms in both half reactions and product terms. We simplify the reaction as much as possible by reducing the coefficients. So maybe everything can be divided through by 2. So we do that. Also, if we have species on both sides, we will subtract so that we will end up with them only on one side. And the balanced reaction, that can occur then only in acid, but that's okay because commonly reactions are done in acid. Okay, we will skip step 8. We will just work with reactions in acid. Alrighty, now we'll run through this example. So we talked about steps 1 through 8. We will see them happening now. So step 1 is we have the two half reactions, Br minus forming Br2, MnO4 minus forming Mn2+. Those are our two half reactions. That's step 1. Step 2 is we balance the elements other than oxygen. So we have two BRs on the right side in step 1, so we put a big 2 in front of the Br minus in step 2. Okay, now we've taken care of the bromine half reaction. We look to the other one. We're only looking at the manganese. We're ignoring the oxygen for now. We have 1 on each side, so that half reaction is unchanged, therefore the ditto symbol. Reaction 3, now we look at oxygen. Well, our step 2 bromine half reaction has no oxygen, so it's going to be unchanged, so ditto. But our step 2 manganese half reaction has 4 oxygens on the left side, so we add 4 waters to the right side. Step 4, we pay attention to hydrogen. Well, the bromine half reaction in step 3, step 2, has no hydrogen, so we do nothing there, ditto. The manganese half reaction in step 3 has 4 times 2 or 8 hydrogens on the right side, so we add 8 H pluses on the left side. Step 5, now we balance charge. So step 4, step 3, step 2, we have a -2 for the bromine half reaction on the left side. We have a neutral 0 charge on the right side. All we can add are electrons. We can't add something positive. We can only add something negative because electrons are what's involved in a redox reaction. So what we do is we add 2 electrons on the right side. Now we have a -2 net charge on each side for our bromine half reaction in step 5. Step 4 for the manganese half reaction, if we look at step 4, what the net charge on the left side is, we have 8 minus 1, we have +7 on the left side. The net charge on the right side is +2. So we have to add 5 electrons to the left side of our manganese half reaction so that we have +2 net charge on each side. Step 6 is we make the electrons balanced. So we have 2 electrons involved in the bromine half reaction, step 5. We have 5 electrons involved in the manganese half reaction, step 5. So we multiply each half reaction by 5 to make for 10 electrons on each side. So we have then 10 Br minus yields 5 Br2 plus 10 electrons for step 6 for the bromine half reaction. Multiplying the manganese half reaction by a 2 to have 10 electrons involved in both sides. We have 10 electrons plus 16 H plus 2 MnO4 minus, yielding 2 Mn2 plus 8 H2O. So again, step 5 required that we have the same number of electrons. Well, step 6, coming from step 5, required that we have as many electrons formed as we have electrons needed. So we have to multiply step 5 bromine by 5 to get 10 electrons, and we have to multiply the manganese step 5 half reaction by 2 to end up with 10 electrons. So that's what we did. So step 6 of bromine is multiplying through by 5. Step 6 of the manganese half reaction is multiplying step 5 through by a 2. Now step 7 is we combine our 2 half reactions. So we take everything in each half reaction on the left, yields everything in each half reaction on the right. So we have 10 Br minus plus 10 electrons plus 16 H plus 2 MnO4 minus yields 5 Br2 plus 10 electrons plus Mn plus 2 Mn2 plus 8 H2O. Now we cancel out what appears on both sides, which are those 10 electrons, and we look at our reaction. Can we divide everything through by a 2 and still have whole numbers? Well, no, we don't want 5 halves. Do we have water on both sides? No, we only have it on one side. Do we have H plus on both sides? No, we only have it on one side. So our reaction would be stopped with 10 Br minus plus 16H plus 2 MnO4 minus yields 5 Br2 plus 2 Mn2 plus 8 H2O. Now we can double check that our overall balanced redox reaction, at least in acid, is correct by making sure we have the same number of each electron on the left side as on the right side, and that the overall charge on the left side equals the overall charge on the right side. So let's run through and do that. We have 10 BRs on the left side. We have 5 times 2, or 10 BRs on the right side. We have 16 H's on the left side. We have 8 times 2, or 16 H's on the right side. We have 2 Mn's on the left side. We have 2 Mn's on the right side. And oxygen, we have 2 times 4, or 8 O's on the left side. We have 8 O's on the right side. So element-wise, we're balanced. Now let's look at charge. We have on the left side, negative 10 plus 16 is positive 6, minus 2 is positive 4. Looking at the right side, we have 2 times positive 2, we have positive 4. So it is completely balanced so that we can feel confident that our reaction, that balanced in acid step 7 reaction, is done correctly. We will skip step 8. That is if it were not done in acid but were rather done in base. We will skip that. We can skip the pre-activity and then just do the report. So problem number 1 gives us a redox reaction, and what we are to write in the blanks above each element is the oxidation number. So the lithium solid, well, that's a metal. What's its oxidation number? The chlorine, it's part of the ionic compound CuCl2. What's its charge? That's going to be its oxidation number. Same deal with the chlorine. It's chloride. It's part of an oxidation, an ionic compound. It's got a charge. Its charge is its oxidation number. Apply that same stuff to the products. What's been oxidized? What lost electron? What's been reduced? What's gained electron? What caused the oxidizing? That's the oxidizing agent. What caused the reducing, and so forth. And then you answer each lithium atom will either gain or lose electrons, and how many. Do the same thing with copper. The amount lost should equal the amount gained, and H has you indicate how many electrons have been transferred from the one to the other. Problem number 2 is very similar. You have a different redox reaction, so I would, if I were you, even though there's no blanks above the elements, I would write what their oxidation numbers are so that you can answer all the questions. Question 3 is similar. You're given a new redox reaction. Again, I would determine the oxidation numbers of each species involved by writing them above, and then answering all the questions. And the next one is you're given a redox reaction, CH4O plus Cr2O72 minus, forming CH2O plus Cr3 3 plus. So what you're going to do is run through those balancing redox reaction rules that we went through, steps 1 through 7, to balance this reaction. So first, separate it into the two half reactions. So of course the carbon containing compounds are going to be one of the half reactions, and the chromium containing ones are the other. Balance with respect to elements other than O and H, that's step 2. And then step 3 is balance oxygen by introducing water as needed. Step 4, balance hydrogen by introducing H plus as needed. The next step is to balance the charge by adding electrons to each side, the appropriate number. And then the last step there, called electrons here, is to multiply each half reaction by the coefficient needed so that you have as many electrons used as you have formed. The last step is to combine the two half reactions, dividing by any like 2 if needed, taking care of water if you have water on both sides, eliminate some so that you have water only on one side. Same deal with hydrogen. Next then, you fill in the coefficients for each reactant and each product, adding water to the side that's needed and adding H plus to the side where it's needed. That's what's meant by you must include any that are missing. That would be the water and the H plus. Okay, so that reaction was done in acid. This next problem is to have you go through step 8. We did not do that. You can skip this, and doing it in basic solution. And problem number 6 is having you do another balancing of a redox reaction. That's this one here, I minus plus IO3 minus forming I2. Running through the steps, you're not given the table to fill in, but I would highly recommend that you go through steps 1, 2, 3, 4, 5, 6, 7 as we went through so that you can balance this redox reaction. Now notice that we have 2 reactants, but we only have 1 product. What that means is I minus forms I2 as one half reaction, and IO3 minus also forms I2 as the other half reaction. So that's your step 1, the 2 half reactions. Go through all the steps so that you finally have your overall balanced redox reaction. So in the blanks here in front of the I minus and the IO3 minus and the I2, you put the coefficients you found, include water on whichever side it is needed, and include H plus on whatever side it is needed. Okay, so that is the end of this redox reaction activity. So when you are done with it, do a double check, make sure you're happy with it, scan it, preparing a PDF file, and submit it.